A function that can be represented in the form of f of x equals ax squared plus bx plus c is called a quadratic function. Nice wolves. Okay, so f of x equals ax squared plus bx plus c is a quadratic function. Okay? What kind of function, what would we call this? Begins with a P. A polynomial that's written in standard form. What's the degree of this polynomial? 2. What kind of polynomial is this? Trinomial. And what's the leading coefficient? Sweet. Okay, so we know a little bit about a quadratic function here already. But before we dive deep into that, let's start from the beginning. Let's say instead of going straight to a quadratic function, I just start with this last term here, c. And I say that my function is equal to c. Okay? Well, what would the graph of that function? First off, a, b, and c are just constants. So that means c is just a number like 1 or 2 or 3 or negative 5 or whatever. What would the graph of that function look like? Just a number like f of x equals 3. What would that be? What would that look like?
Straight down.
A vertical? Yes. Every class I've gotten that same answer, and it's incorrect, and it's okay. I appreciate your bravery. That's strong and brave of you, sir. Courageous. It is not a vertical line, it is a horizontal line. Okay? Why? Because the function always equals a constant, or in other words, the function is constant. It doesn't vary with x. No matter what x is, it is constant. Okay? So what, I hope I didn't make you feel bad, Mr. Bolton. I meant to make you feel good. Sorry about that, sir. So it's constant, which means it's just a straight line, guys. And it's not a vertical line, it's a horizontal line. Okay? Does that make sense, guys? Okay, so no matter what x is, had some major gains, huh, Mr. Barreto? Huh? There you go. Nice. Okay, all right. All right, so our function is constant, okay? It doesn't vary with x, all right? So that's cool. What kind of polynomial is that? Monomial. And what's the degree of this polynomial? The degree is, it's not 1, because that would be x to the first power. 0. Why? Because x to the 0 is technically 1, so it's like 1 times that. So it's degree 0. So a 0th degree function, or a polynomial of degree 0, is just a horizontal line, a constant function. Okay, does that make sense? It doesn't vary with x. That's a polynomial of 0 degree. But now let's move on. What if not just the c component, but this bx component I used as well? And I say f of x equals bx plus c. Well, what would that function look like? Now, this might be hard for you guys to see, but if I said it a different way, I bet you'd see it. What if I said f of x equals mx plus b? What would that be the graph of, or function for? A line, right? A line with a slope, right? A line with a slope means that it varies with x, right? Could the slope be positive or negative? Could be anything, right? Could be either. Okay? So here you go. Here's our function. Right there. Okay? Bam. Mr. Sanchez, why don't you scoot one back?
One back? Right.
Yeah. I'm not feeling like I'm just blocking. Alright. Better, right?
Yeah.
Okay. There you go. Alright. Now, what kind of polynomial is this? Binomial. And what's the degree of this binomial? 1. So, a polynomial of degree 1 is a function whose graph is a straight line that varies with x. It's either got a positive slope or a negative slope, right? Okay, so this is a polynomial, and this function varies with x because this bx term says as x changes, my function changes, right? You see, there's no x term here, so my function doesn't care about x. Here's an x. My function cares about x. As x changes, my function changes. Get it? Does that make sense, guys? And as x changes, either my function is going to go up with a positive slope or down with a negative slope if x is increasing. You guys understand this? Okay, so we understand this, but now we're understanding it as polynomials, right? Polynomial of degree 1. Okay, but now let's include everything. Let's include all 3. And we get f of x equals ax squared plus bx plus c. And what is the shape of this function? What is it called, guys? Come on. You guys must have not done your bell ringer. What's it called? Parabola. Parabola. It's called a parabola. Very good, guys. It's called a parabola. Thank you, thank you, thank you. It's called a parabola. Got it? Now, shh, 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 shh. What's the degree of this parabola? 2. Of the polynomial, I should have said. The polynomial class here, listen. A polynomial of 0 degree is a constant function with no slope, right? It doesn't vary with x. A polynomial of degree 1 does vary with x and either has a positive or a negative slope. It's right up. Shh. Pay attention. A polynomial of degree 2, listen, is a what type of function? Quadratic function. And the graph of a quadratic function is a parabola. You see? Now look. A quadratic function varies with x and with x squared. You see this? See this? It varies according to x squared. Okay? You guys get that? Okay. Now look. If we want to really understand quadratic functions, we should start with the simplest one. And the simplest quadratic function is simply f of x equals x squared. So at the top of that page there, you'll notice example A and example B, or these questions A and B here. It asks us to start by creating an x f of x table for the function f of x equals x squared. So let's do that. This is -3, this is -1. What goes in between? -2, good. You notice all we're doing is plugging in the numbers into f of x. So let's plug in -1. F of -1 equals -1 squared. -1 squared equals 1. F of 2 equals 2 squared. 2 squared equals 4. F of 3 equals 3 squared. 3 squared is what, class? Good. So we've created our table simply by plugging in. We've done this many, many times with different functions. Okay. So we just created our table, our x, f of x, t-chart sometimes it's called. Okay. And now it says for part B, plot the ordered pairs as points on the graph and connect the points to sketch a curve. So let's do that. -3, 9. That's here. -2, 4. That's here. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. So I've plotted my points. Now that I've plotted my points, I go ahead and I actually graph the function. Now, class, you may notice that my graph here on my little tablet thing is a little bit squiggly. So if you graph and yours looks a little squiggly, I'm not going to be mad at you. I'm not going to take off any points. I'll understand. It's hard to draw parabolas sometimes. You know, it's easier if you kind of sketch it out, like, you know, you kind of go step by step and you kind of just like, you know, I don't know. It's hard to do it on the tablet, but you understand what I'm saying. You can make it look good. All right? If I can do this on the tablet, you know, you can do it. I think you can. Okay? Not so bad. A little bit squiggly, but it's okay. All right. Now, listen. But what will not be acceptable, because that's what's more important. What will not be acceptable? I will show you what will not be acceptable. What will not be acceptable is this.
Oh, no.
That's not acceptable. That's not a parabola. What also will not be acceptable if you want to achieve full credit on a test? Something like this where you have 1 point and then you just draw it. Okay? That's not acceptable. You guys laugh. I've seen that many times. Okay? Listen. That will not be acceptable. All right?
How many points do you need?
I'm not going to get into that discussion. The point is that will not be acceptable. Okay? You have to draw the points and draw as many points as you possibly can fit on the graph. Okay? It's not always the case that you'd want to plot as many points, but a lot of times that's the deal. Okay? Just plot as many points as you can until you start going out of the domain or range of your coordinate plane, and then you graph it, okay? Does that make sense, guys? Okay, and just try and get better and better at how you do it, all right? And you will get better with time. All right, any questions about what we did here? Okay, all right. Now, before we go on to examples, I want to give you a visual understanding, okay? So I'd like to give you a visual understanding of what we're doing here. Okay, I should just save this. All right. If I just have AX, all right, and I say A is equal to 1. You see this is Desmos.com, right? A is equal to 1, AX squared, okay? If A is equal to 1, then this is the graph of the function that I just showed you, that we just went through, right? Okay? Now, what do you think will happen if I make A bigger? So, for instance, it's 2x or 3x or 5x or 10x. What do you think will happen with the graph? It'll get wider or like this, more narrow? Well, raise your hand if you think it's wider. Raise your hand. Wider and more narrow. Okay, so like one stretch. Okay, let's see, guys. Who thinks it'll explode? No one? Okay. It might. All right, ready? Ready? Here we go. Ready? Oh, look at that. So as A goes up, it stretches it, okay? Guys, remember when we had the absolute value function, we had A, what happened with the slope as A went up? It got Steeper and steeper, right? So it's like a stretch, okay? Bam. Same thing here, okay? Now, as A goes down more and more, it does get wider. It compresses until, now, look, what do you think happens when A becomes negative?
It goes back.
It flips across the x-axis or reflects across the x-axis.
Oh, sorry.
You see that? You see that, guys? Okay, so there you go. There you go.
Bird.
It's the bird.
Bird. Oh,
Okay, remember? Okay, A goes up, down, now it's negative, you see? It goes, oh, look at that. Okay, you guys understand? Okay, so now go ahead and graph step B on page 213. Page 213, step B, please. We have T-chart, plot points, and then go ahead, it's asked for the domain and range. Go ahead and do that as well. Another 20 seconds. You guys remember Hurricane Irma?
No.
What a whirlwind.
We're still the
Okay, there is. It's crazy. Go down to Hollywood. It's so crazy over there. All right. 1/2 x squared. Let's pay attention now. 1/2 -3 squared. -3 squared is 9. 1/2 of 9 is 4.5. 1/2 -2 squared. -2 squared is 4. 1/2 of 4 is 2. 1/2 of 0 squared is clearly 0. 1/2 of 2 squared. 2 squared is 4. 1/2 of 4 is 2. 1/2 of 3 squared. 3 squared is 9. 1/2 of 9 is 4.5. Here we go. -3, 4.5. Careful when plotting 4.5. -2, 2. 0, 0. 2, 2. 3, 4.5. There you go. There you go. Okay, so you're graphing a quadratic function. Next is domain and range. What's the domain of this function? There you go. Solid, Miss Perkins. There you go. You can clap it up for Miss Perkins. Come on. Give it up. There you go. Nice. All right. Negative infinity to positive infinity. That's right. Left to right. It goes on forever. Remember, domain is left to right. So all the way over, all the way over. Negative infinity, positive infinity. Range. What about the range? Very good. Does it include 0? So it has the square brackets, 0 to positive infinity. That's correct. Right? Range is bottom to top. Where does it start? Up. Bam. Right there. 0 includes it. It keeps going up to positive infinity. So that's the domain and range. Got it, guys?
Yes.
Nice. Okay. All right. All right. Now, with that said, I'd like to allow you all to explore a little deeper some understandings here about our quadratic function. So pay attention now. Okay? You may have noticed that I had some things up here. So what if instead of just ax squared it was plus bx plus c? Okay?
You're so wild.
I know. Praise God. Praise God. All right. So first off, this is the vertex, right? This is the vertex here, right? Yes?
Yes.
Okay, that's the vertex. Now, there's also something called the axis of symmetry. Okay? This is the axis, the vertical line that splits the parabola in two symmetric halves. Okay? It's always symmetric. All right? That means if there was a mirror here, it'd be the exact same on the left and the right side. Got it? Okay, so that's called the axis of symmetry. The axis of symmetry always goes through the vertex. Always. Goes right through the vertex. Does that make sense? Now, if A is just equal to 1, that's what it looks like there, right? What do you think will happen here? I've got this plus C here, right? What do you think would happen if I make C bigger? What will happen with the graph? What will it do? What do you think? Move to the right or the left, something, maybe. Move to the right. What else? Any other ideas?
Maybe it'll move up and down.
What happened when I had like a plus number when my absolute value functions? It moved up, right? If it was outside the parentheses, right? Remember, or the brackets. Look at that. So there you go. As C moves up and down, there you go. You see? C is getting bigger, goes up. It's arbitrarily stopping at 10. I could make it anything. Okay? All right? Now B, it's a lot harder to understand, but look what happens when I change B. Okay? So you can see that B obviously affects my graph as well, but the axis of symmetry is always going through the vertex. You guys see that? Axis of symmetry is always going through the vertex. So that's pretty cool. And then if I just do them all at the same time, that's just lots of fun. What?
What was it doing, bro?
It just does all sorts of things. You got to understand that A, B, and C all affect the graph in different ways. And that's what I was showing you. Okay? It's a little bit harder to see how B affects the graph because it's not just like moving it up or something like that. It's like kind of bringing it on this trajectory, right? You guys see that? See? It's kind of cool. Anyhow, so yeah, kind of like a basketball. Kind of like a parabola. It looks like it's tracing a parabola, doesn't it? That's deep. That's deep.
Yeah, like a basketball.
Right? Look, guys, if you bounce a basketball, if you pass a basketball, right? Bing, what is the path that the basketball takes? Okay. If you launch a cannonball, right? If you throw a baseball, boom. If you throw a baseball through the air, what is the path that a baseball takes? A parabola. If you shoot a basketball, same deal. Okay, now, guys, good. Now check it out, guys. Check it out. Look. What about if A is negative? What happens when A is negative? It flips, right? So if my parabola, if A is positive, it points upward. If it's negative, it points downward. Okay, so go ahead now and do step B on page 214, middle of 214. Just like you did here. So step B, middle of page 214, negative 1/2. Instead of 1/2 x squared, it's negative 1/2 x squared. Okay. Now, let's go through this quickly. Negative 1/2, negative 3 squared. Negative 3 squared is 9. Negative 1/2 of that is negative 4.5. Negative 1/2 of negative 2 squared. Negative 2 squared is 4. Negative 1/2 of that is negative 2. Negative 1/2 of negative 1 squared. Negative 1 squared is 1, so that's negative 1/2. Negative 1/2 of 0 squared is clearly 0. Negative 1/2 of 1 squared is negative 1/2. Negative 1/2 of 2 squared. 2 squared is 4. Negative 1/2 of that is negative 2. Last one, negative 1/2 of 3 squared is 9. So that's negative 4.5. Okay, plot the points. Negative 3, negative 4.5. Negative 2, negative 2. Negative 1, negative 1/2. 0, 0. 1, negative 1/2. 2, negative 2. 3, negative 4.5. Good. Go ahead and plot your parabola. Okay. There you go. What's the domain? There you go. Nice. Negative infinity to positive infinity. So goes all the way to the left, negative infinity, all the way to the right, positive infinity. Range, bottom to top, right? Goes all the way down to negative infinity, and where does it stop? 0. Does it include 0? Yes. So negative infinity to 0. And bam, there you go. There you go. That's the domain and that's the range. Now look, if A is positive, A is greater than 0, the parabola points upward, right? Yeah? And the vertex is technically a what? It begins with M. minimum, a linear. Technically, no, it's a minimum. If a is less than 0, the parabola points where, class?
Maximum.
Down, and this is a maximum. The vertex is a maximum. Okay? So if a is positive, it points up, and the vertex is a minimum. If a is negative, it points down, and the vertex is a maximum. Does that make sense? Okay? If it's positive, it points up. Negative, it points down. And then from there, it's easy to see, hey, that's a minimum, and that's a maximum. Does that make sense?
Sir.
Okay, good. Good job, class. Any questions on what we've covered so far? Okay, cool. We have one simple aspect left of the lesson. We have now learned how to graph the simple quadratic functions when the form is just ax squared, right? We didn't have any bx or c terms, right? Just ax squared. And where was the vertex in all of these graphs? 0, 0, right? Okay. So when the vertex is at 0, 0, when the vertex is at 0, 0, the function is of the form ax squared. When the vertex is 0, 0, the function is of the form ax squared. Okay, and this is important for our next step. And our next step starts on the next page here, 215, where we are now writing a quadratic function when given a graph. So now, before we were given a function and we made the graph, now we're giving the graph and we need the function. Does that make sense? So here we go. Where's the vertex of this graph? 0, 0. So the function is of what form? Ax squared. So I know this function, I'm trying to determine this function based on the graph. So I know this function is of the form ax squared. I have this point, right? And I know a point is of the form x f of x, right? So what should I do with that point? What should I use that point for? X and f of x, y, f of x. And what should I do with that in that equation? Plug it in. There you go. In this case, both x is equal to 2 and f of x is equal to 2. I take those values and I plug them in. F of x equals 2. A times x is 2, so 2 squared. Or 2 equals a times 2 squared is 4. What do I do next, class? Divide by 4. And I end up with a equals 1/2. So look, I knew the form of the function was f of x equals ax squared because why? Because the vertex was at 0, 0. What's that point called? 0, 0? Because it's an O. Origin. Yes. If the vertex is at the origin, my function is of the form ax squared. Okay? I'm also given a point 2, 2, which I then can use. I know x is equal to 2 and f of x is equal to 2. So I plug those in. 2 equals a times 2 squared. I end up with 2 equals a times 4. Divide both sides by 4. I get a is equal to 1/2. What do I do with this a now? Plug it back in to get my function. F of x equals 1/2 x squared. And I've gotten my function based on my graph. Does that make sense to you guys?
Yes.
All right, good. So I use my graph to get my function. Simple as that. What did I do? I start with the form f of x equals ax squared, and I plug in the point. Solve for a, bring it back into the function, and I'm done, right? Plug in the point, solve for a. Got it? All right. Now, go ahead and do step B on your own, just like we did step A. Plug in the point, solve for A. Go ahead, step B. Okay. Let's give it a look. Where's the vertex of this function? At the origin, right? 0, 0. So my function is of the form f of x equals ax squared. I've been given my point. X equals -2. F of x equals -8. Plug it in. -8 equals a times -2 squared. -8 equals a times -2 squared is 4. Divide both sides by 4. I get a equals -2. Why does it make sense that a is negative, class? It's facing downward. It's pointing downward. I take my value of a. I plug it back in for my function. F of x equals -2x squared. And I'm done. Final answer. Got it? Yay. Okay, that's it. Any questions? Okay, homework. What is your homework? Your homework is on the bottom of page 218. It starts at number 1, and then it goes on through number 15. Number 14 and 15 is kind of like it's a word problem. Go ahead and take a look at that and do the best you can. Numbers 10 through 13 are like what we just did, where you're determining the function. All the vertices are at the origin, so it's all ax squared. And numbers 2 through 9, if you look, you're just graphing the function. It doesn't give you a table, but it does give you these coordinate planes. Now take a look, class. It gives you from -4 to 4, basically, or really -5 to 5. So it wouldn't make sense to start a table with x equals -18 or +30, right? So which number should you use? These ones, -2, -1, 0, 1, 2. Okay? You won't always use those. If you want, you can use 4 or something, but I just recommend you use these numbers because generally they're the easiest. Okay? So I'll be looking for that in your homework. Make sure you have a t-chart. You plug in x, each one is f of x, and then you'll solve. Sometimes, like, the only point will be the origin. It depends. You know, you'll just have to do your best, okay, and plot the best that you possibly can. But make sure you fill out this t-chart first and then plot your points. Got it? Okay, any questions? Okay, good. Yes. All right, good job, class. So you've got about 6 minutes to do your homework. Go ahead and get started.